Hello and welcome back to my Arduino and electronics channel. My name is John and this is the number 5 in a series of videos about Arduino and electronics. In this video we will try to understand how analogic inputs works, and we will see how to use analogic outputs too. In the previous tutorial we built a circuit with a push button and an LED. We will elaborate on that, using a potentiometer as input instead of the push button. This is the circuit we ended up with last time. If you do not have it, I suggest you take the time to watch part 4 before going on with this. In this circuit we were using a digital input, that is something that can be on or off, but what if we need to use an analogic input? An analogic input is something that has a variable value from a minimum to a maximum, such a temperature sensor, a volume knob, or something like that. In Arduino there are 6 analogic inputs, that are not really true analogic. This means that their value cannot vary in a continuous way, but they are varying in steps. In Arduino there are 1023 steps, from 0 to 1024, that represent the voltage applied to the analogic input pins. These pins can accept a maximum voltage of 5 volts, so 0 volts will give a value of 0 and 5 volts will give a value of 1023. Let's have a look at how a potentiometer works. It has a resistive strip and a sliding contact, called wiper. When we move the wiper, we change the length of the resistive strip that the electrons must follow, thus changing the resistance. So if we connect the sides of the potentiometer to ground and 5 volts, we will obtain a changing voltage on the middle. Now remove the push button and its connections from the breadboard, and place a potentiometer instead. Connect the right side to 5 volts and the left side to the ground. Now the central pin, the wiper, to A0 and go to our Arduino IDE. Start a new sketch, and as first thing give a name to our analogic input pin, let's call it potentiometer. Now, as we did last time, we create a variable to store the value and then read the input. We will call the variable input value, and we will use the instruction analog read. Note that it is not necessary to set the pin to an input, as they are set to inputs by default. Now it would be nice if we could actually see the value that we are getting from the input, and as it happens, we can do that using the serial monitor. Before using it, we must tell Arduino that we want to open this communication channel with our computer, and we do so using the command serial begin. The parameter for this is the speed at which the communication will happen. We will use the standard 9600. After we initialized the serial communication in setup, we can add a line in loop to actually print out the value. This is done with the command serial, println, using our variable as parameter. This command will print the value on our computer screen. Let's upload the sketch and see how. Open the serial monitor using this button on the top right corner, and this window will appear. As you turn the potentiometer you should see the value change from 0 to 1023. If this is not happening, please check that everything is wired correctly. You may notice that the values are printed out very quickly, so we can add a little delay to our sketch to make it easier for us to read, let's say 100 milliseconds for instance. Now it is easier to see how the value change as we turn our potentiometer. Another way to visualize the value is the serial plotter. Let's close the serial monitor and go to Tools, Serial Plotter. Now the value is shown in a graphic format that is very useful to visualize how it changes. So far, we were able to read the position of the potentiometer, and we can use it to do something useful, for instance changing the brightness of our LED. We can do that using a technique called PWM, pulse width modulation. Let's have a look at how it works. Instead of changing the output voltage, we can switch it on and off very quickly at a fixed speed and varying the time in which the output is on. This time is called duty cycle and can change between 0%, which means that the output is always off, and 100%, which means the output is always on. Everything in between will see the signal on for a certain time and off for the rest of time. For instance, at 50% the output will be on for half the time and off for the other half, and at 75% the output will be on for 75% of the time and off for the remaining 25%. This can be easily done in Arduino using the analog write command, but not all of the pins have PWM capability. On the Arduino Uno we can use PWM on pins 3, 5, 6, 9, 10 and 11, so we need to move the LED connection to a PWM enabled pin. We will use pin 11. In the Arduino IDE, add the definition for the LED pin, this time using 11 as value. Now in the loop function we can add the command analog write, LED, input value. This will set the PWM value to the value of our input, but there is a catch. The PWM output value can vary from 0 to 255, while we saw that our input can vary between 0 and 1023, so we need to adapt those two values, and we can do so using the command map. Add this line before the analog write, int PWM out equals map input value, 0, 1023, 0, 255. We are creating a new variable, called PWMOut, and we use the command map to take the value of the variable input value, that can vary from 0 to 1023, and we adapt the value to range from 0 to 255. Now we change this line as well, sending to the output the value of this new variable. Upload the sketch. And now we should see that we can control the brightness of the LED using the potentiometer. This is all for today. We now know how to read an analogic input and how to write an analogic output to a pin. Next time we will see how we can use an analogic input to light up different LEDs depending on the input value. I hope you enjoyed this video and I hope to hear your comments and suggestions. If you liked it, you can leave me a like, and subscribe to my channel so you will not miss the next videos. See you soon on Arduino and Electronics channel.